Let's look at an example of using the binomial expansion to get the first 4 terms of this. Notice that I say 4 terms because we're going up to x cubed. Our first term will be a constant term with no x's in it. So let's imagine that we had 8 of these brackets all multiplied together. My first term, which would involve no x's, would just be 2 times 2 times 2 times 2, 8 times. So our very first term in this expansion is just going to be 2 to the 8. Imagining those 8 brackets, each time I multiply out, I would just choose that first term in each, 2 times another 2 times another 2, and so on. When I look at the next bracket, I'm going to have 2 times 2 times 2, and I'm going to have 7 of those 2's multiplied together, and 1x. So notice that the power of the 2 has reduced by 1, and then I'm going to multiply by an x. Notice, however, that I cannot multiply by just an x. If I'm going to choose this term, I must multiply by minus 3x. We now need to try and work out the coefficient of this term. How many ways can I choose one of these x terms from 8 brackets? So, if we do n choose r, so n choose r, how many ways are there to choose r terms from n brackets? We want just one of these terms, so we're going to do 8 brackets, choose 1. And there's 8 ways of doing that. If we think that through, it makes sense. 8 brackets, how many ways can I choose just one of those? There are 8. You could choose it from the first, second, third, and so on. Okay, let's look at the next term. So remember, I'm going to have 1 less 2 again, because I'm now going to choose 2 of these. I want an x squared, 2 to the 6, multiplied by, now I want 8, choose 2. How many ways can I choose 2 objects from 8 brackets? There are 28 ways to do that. This is less intuitive, but if we think of that video which explains these coefficients, that's because I would have 8 choices for the first, 7 choices for the second, but then they could be swapped around. So I need to divide by 2 because I've overcounted. 4, 8 divided by 2 times 7 is 28. So that's where that number comes from. We can just use our calculator for now though. Okay, and then like we said, we're going to have 2 of these terms. So remember, each time I multiply by an x, I'm also multiplying by a minus 3. So it is very important that you have minus 3x squared, not just this. We are not just squaring the x, we must square the minus 3 as well. Otherwise you will get the wrong coefficient of x squared. Okay, our final term, and 1 less 2 again, multiplied by 8, choose 3, 56, and then multiplied by minus 3x cubed. I've gone up as high as they wanted me to. Now I can just put all of these into the calculator. 2 to the 8, 2 to the 8, 256, 2 to the 7 times 8 times 3. Notice that I've not put the negative into the calculator. I always think it's best if you sort out the sign yourself. You've got 1 negative in this, the term will be negative. If you start putting negatives in, especially when you're squaring stuff, unless you're very careful and you put in brackets as you're supposed to, you will get errors on your calculator. It's generally easier to just go 1 negative sign negative, 2 negative signs positive, 3 negative signs negative again. An even number of negatives will always be positive, an odd number of negatives will always be negative. Using that logic, we know this next term is positive. We then have 2 to the 6 times 28 times 9, 16128 x squared. Final term, 2 to the 5 times 56 times 27 Again, I know this is negative, so I'm not putting negatives in my calculator. I have the first 4 terms of this expansion, and I've expanded it up to x cubed. Remember, there is a first term with no x in it. Also, you must square and cube the coefficient of x, including that sign. Forgetting to do that will lead to incorrect coefficients once you've done your expansion.